February, week 3, math, 3rd grade, lesson 3. Who remembers what we learned yesterday? Griffin, do you remember?
The properties.
Properties, good. Properties for multiplication. Do you guys remember the names of any of them?
Commutative.
Commutative,
Associate and distributive.
Associative, good.
And distributive.
And distributive. Commutative was if you say 2 times 4, right? It's the same as 4 times 2. Okay? That's commutative.
Still makes sense.
Associative, do you guys remember? It's who's associating with who.
You can
So
switch
if
it
you
up.
have 3 factors and you say 2 times 4 times 6, you can also put the 4 and the 6 together and leave the 2 somewhere in the library or whatever.
Or
Okay?
getting
All that means is that in this one, those 2 factors are associating more closely, and in this one, those 2 factors are associating more closely. That's all. And last, the hardest one, distributive, is the truck.
Also, the hardest to say.
Also the hardest, yes. And that one says if you have 3 times 7, that's a nice, let's do 3 times 7. You can say that that's the same as 3 times
4.
The easiest ones is 5 and 2s, I think. 5 plus 2, right?
4 could be 3 times 4.
Which would be 3
7.
times 5 plus what?
Plus
3 times 2.
Yeah.
Okay? That's the distributive one. It's basically a truck full of stuff. Imagine that the 7 is how many barrels of salted fish are in a truck. The truck stops at Delta and drops off 5 barrels, but then the truck drives to Hotchkiss and drops off the other 2. Nothing changed, it just distributed what it had into 2 different groups, and they're in 2 different places. So that's that distributive property.
That helped.
Definitely the hardest one.
That helped a lot
When I said that,
explaining it. Yeah.
okay. There are many strategies you can use to solve multiplication and division. You can skip count, so for 5 times 6, it's funny that they're doing their 6s. I would do the commutative property and just do 6 5s, but 6, 12, 18, 24, 30, okay? You can also add, so you can do 5 times 6 is, sorry, you can add 6 5 times. Then you can do, that one's kind of hard. 0 plus 6 is 6, 6 plus 6 is 12, 12 plus 6 is 18, 18 plus 6 is 24, 24 plus 6 is 30. That one's for if you don't know your 6s, right?
Most of us do.
Most of you do, but even if you don't, I would use the commutative property and just do 5s and do 6 times 5 on that. But that is one way you could do it. Then you could do doubles. You could do 5 times 6 is the same as 5 times 3 plus 5 times 3. That's the distributive property, isn't it? Right? That's what that person did, which is 15 plus 15, which is 30. To solve 30 divided by 6, you can use multiplication. Just skip count your 6s. That's the quickest way. Okay, 6, 12, 18, 24, 30. And the answer would be
30. 5.
5. Okay. You can also use repeated subtraction, which is super hard. 30 take away 6 is 24. 24 take away 6 is 18. 18 take away 6 is 12. 12 take away 6 is 6, and 6 take away 6 is 0. And you had to do that 5 times. So the answer would be 5. Which way was easier? Definitely skip counting, right? Yeah. This one's really hard to do. But it does work. Let's go to the next page.
It will help you.
Complete each product to compare each product to 50 and write them in the correct box. Less than 50, greater than 50. Okay? 5 times 9.
Yep.
Griffin.
9, 18, 27, 26, 45.
So where's that going to go?
Less than 50.
Okay, on the next one, By the way, Griffin, they did skip counting just like you, which is terrific. The next one, 7 times 7. Again, it looks like they're doing skip counting. Is anyone really good at their sevens? Gage, want to try? 35. You're almost there. 42 and 49. So he got most of the way there. Is that less than or greater than?
Less than.
Less than again. And the quickest way for me to remember 7 times 7 is actually not to skip count. It's the football. Remember? So when you score a touchdown plus the 2 extra points, it's 7. And it's almost always 7. So the only football team that has a number for their name is the San Francisco 49ers. So 7 times 7, you can remember that way, is 49.
I don't watch football.
So that can help a little if you can't do your sevens. For 8 times 7, skip count by 1 more. So we got to 49.
56.
56. So see the 8 times 7, where's that going to go?
Greater than.
Greater than. So Gage, what Silas did was he took your 49 that you did and added 1 more group of 7 to get 8 groups of 7, okay, which was pretty efficient rather than just skip counting all over again.
Much easier.
Okay, for 6 times 8, they're splitting that into 6 times 4 plus 6 times 4, and they're saying that's 24 plus 24, 48, less than 50. And for 9 times 6, they're splitting that into 9 times 3 plus 9 times 3.
So it's 54.
Right. Next page. Draw a line from each division problem to its quotient. The first one is 42 divided by 7.
7.
No.
Wait.
Gage, can you help us with our sevens?
7,
14, 28, 35, 42. Stop. Okay, you did it, buddy. It's 6, right? Did you have 6 fingers up?
Yeah, but I tried to pull down.
Uh-oh, you drew the line to the 7. Yeah, always keep your fingers up. Don't put them down, okay? 7, 14, 21, 28, 35, 42. Don't put your fingers down, then. You got to remember it's 6, okay? All right, who wants to try the next one? Griffin.
Well, I have a...
Oh, okay. Silas.
9.
Yeah, but can you show us?
Okay. 9, 18, 21, 27, 36, 45, 54, 63, 72, 81.
And it is
9. I just know my 9s.
9. Good job. 63 divided by 9. Who else would like to do some 9s? Reuben, you've been kind of quiet. Could you get us there, buddy? Don't forget your fingers. Shh. Gage, that's not cool. Nice and loud.
9, 18, 27, 36, 45, 54, 63.
It is 7.
No help from Gage.
The next one, 40 divided by 8. Gideon.
8.
Try skip counting.
8, 12, 6,
Try again.
8, 8, 16, 20.
Don't forget your fingers.
8, 16, 24, 36,
32.
32, 45. Ooh, I don't know my 8s that well.
Okay, do it with Silas together.
8, 16, 24, 32, 40.
And stop.
It was 5.
Yeah, don't put your fingers down till you. The next one has to be 8. And it is 8. 8 too much and got sick on the floor, so 8 times 8 is 64.
I don't know that one.
That one's kind of a fun Now, they used some different strategies here, but we did it all by skip counting. And that's pretty cool. That means you guys know your facts pretty well.
And some of them probably looked on the bottom with the solutions.
Maybe, but I made you all skip count, didn't I? Yep. Let's go to the next page. And it says, select a fact you can use to solve the division problem and mark all that apply. So there's probably going to be more than one. There might be 2 or 3. So the problem is 56 divided by 8. Ready? A. 8 plus 54 makes 62.
No.
That does not help at all. I'm so glad you all said no. B. 8 times 7 is 56.
Yes.
That's a big help. All right. We're definitely going to choose that one.
Yeah, that first one is a big help.
That first one's a doo-doo, right?
That's funny.
It has nothing really to do with it.
Yeah, but it does equal 16.
Yeah, which doesn't matter. Okay, C. 54 take away 46 is 8.
No.
That doesn't help us. You notice they're trying to use some of the same numbers, right, to confuse you, but that really doesn't help us at all. So, D, 7 times 7 is 56.
Yes.
Wait a minute, guys. Is it?
No.
What is 7 times 7? I just told you guys about football. Right?
46. I mean 49.
You didn't tell us about football?
Yeah,
If
I
you did.
said it. That's how you can remember 7 times 7.
The 49.
Touchdowns have 7 points, and the only team with a number for their name is the 49ers. So that'll help you. 7 times 7 is 49. It's only B. Oh dear, I thought it was going to be more than that. Okay, it says something and division are inverse operations. So what is the inverse of division?
Division. I mean,
Switching times. Good. We're just going to do bam. Okay.
Bam.
Inverse means opposite, but in math. Okay. Silas and Ruben and somebody else are doing crosswords, and a lot of times it uses this word, antonym. Antonym is another way to say opposite, but not in math. In math, you say inverse. All right.
Oh, I forgot that.
Remember the word antonym? Yeah, it means opposite.
Well, I knew antonym meant opposite, but I forgot inverse meant.
Yeah, I've only told you that once. So
Yeah.
So that means that something does the opposite of division. Times. Good. Gage, you need to be on the rug and focused. To divide 56 by 8. Good. Think something times what number equals 56? 8 times what number? 7. Well, we don't know, right? And then we skip counted our 8s. 8. And it's 8 times 7. Made 56. So 56 divided by 8, I can use times. Right? Oh. And that's why so many of them were terrible. One of them was a plus, one of them was a takeaway, and then the bottom one was a times, but it wasn't correct.
So it was supposed to be only one, or else it would be messed up.
Yeah. Okay, number 1. Draw a line to connect multiplication problems that have the same product. Okay. Better.
1 times 10 is the same as 2 times 5.
Yep.
That's a really easy one.
Not for some kids. Gideon.
4 times 3 is the same as 2 times 6.
Yes. Ruben. Ruben got the hardest one. Yes.
Can I do it?
They both make 24. And then the last one.
Of course, it's 3 times 3. 9 times 1.
That makes a really cool pattern.
Yeah.
I like it.
I'll have to use that.
Okay.
It has a diamond in the middle.
Yeah, it's really interesting.
Whoa.
Number 2. Circle the numbers that make a true statement. The inverse of 2 times 9 is 18.
Ding.
True. Okay, which one?
It is 9 times.
It's the bottom one. Good.
Yeah, that one.
Oh, wait. No. because they're both timeses, so we can't do that one. Okay, let's try the middle one. The inverse of 3 times 6 is 18 is
18 divided by 6 is
yes, and that time this is really inverse, so we get to circle because division and multiplication are inverse. So there we go.
You said the.
I was wrong. Yeah, Silas, I thought that the first one was going to have an inverse, but then it was a times again, so I stopped. But the second one does have an inverse. Okay, number 3. Is the product correct? Select yes or no. 7 times 8 is 56.
No.
Well, actually, yeah, we already said that a couple times, didn't we, on the other page? So that's a yes. Next one. 9 times 6 is 54. Who wants to count their nines?
Who?
Silas.
It is.
9, 18, 27,
36.
36.
Keep going.
46,
45.
45, 56.
Nope. 54. 9, 18, 27, 36, 45, 54.
Yes.
Correct. You got a little mixed up at the end, didn't you? 8 times 8 is 54.
No.
No, but that's close. 8 too much and got sick on the floor, so 8 times 8 is 64. So that's enough. D. 8 times 5 is 45.
No. Yeah.
Let's see.
5 times 13, 20, 25, 30, 35, 40. Yes.
40.
I mean, no. Yes.
No.
No.
E. 5 times 7 is 53.
Yes.
Well, skip count your 5s till you get to 7 of them.
5, 10, 15, 20,
No.
25, 30, 35. No.
See, every time you say that, it's wrong.
And the last one. 9 times 4 is 36.
Yes.
No. Yes.
Well, let's count our 9s.
18, 27, 36.
36, right? 9, 18, 27, 36. Yes. Bottom problem. Write a multiplication fact that you can use to solve the division problem 81 divided by 9. So we need a times fact that helps us solve this.
40.
Gideon.
9 times 9.
Very nice, Gideon. Gotta tell you something, last year that was a struggle, so great job. Because Gage was whispering it over here too. Do you all get that?
People know their lines here.
Very nice. Okay, let's go to the next page.
21.
27. Okay, number 5. Is the quotient correct? Quotient means the answer of a division problem. Okay. 30 divided by 5 is 6.
False.
Count your 5s.
5, 10, 15, 20, 25, 30. Yes.
It's true.
I forgot about time.
Next one. 20 divided by 4 is 9.
Yes.
Is 5. Yes, right? 4, 8, 12, 16, 20. Yep. Next one. 36 divided by 9 is 6.
No.
I don't know. Let's count. 9, 18, 27, 36. Ooh, definitely no.
No. Oh.
You guys were all correct. That is false. D. 21 divided by 7 is 4.
Yes.
Well, let's count our 7s and make sure.
7,
14, 21. So it's only 3.
No.
E. 24 divided by 3 is 8.
No. Yes.
Well, count your 8s. 8, 16, 24.
Yes. Yes.
Yes.
Why am I getting so many white?
I
I
don't know.
usually get them
You're starting to
so
get your math facts down, I guess.
Well, what I'm doing is when they say no, I choose the other one because
Oh,
it's
Silas, that's not a very good strategy. Okay, last one. 14 divided by 2 is 7.
Yes.
2, 4, 6, 8, 10, 12, 14.
We don't even have to count. This time I do.
It's a pattern.
It is a pattern.
It's a weird arrow.
Two, false, false, two, false, false, two, false, false, two, false, false, two. You say that too much.
Gideon, you do need to sit up.
You don't say it enough.
6. Draw a line from the multiplication or division problem to its product or quotient.
Can I do this one?
Sure, Silas. 42 divided by 6.
Okay, should we count by 6, 12, 18, 24, 30, 36, 40. 42. So it's 7.
Good job. Going all the way to the bottom.
I
Who'd like
did
to do
it.
B?
Huh?
Griffin? You want to do B?
I'm gonna do the hardest.
C. Okay. Gage. B.
4, 8, 12,
32. Up to the top. Okay, Griffin, you want to do C, don't you?
Yes.
Okay. 36 divided by 6.
6, 12, 18, 24, 30, 36.
Stop.
6 times 6 is 36.
Thank you, Gideon. Did you hear that? 6 is our thirsty 6s. So 6 times 6 is 36. Okay, D. 35 divided by 7. Gage. 35. You did it. Yep.
The other one is out there.
And the other one has to be 3 times 7 must be 21.
If you don't know that, you all messed up.
Number 7. Sophia has 40 pumpkin muffins. Wow.
Ow.
Wish I was her.
I would be chopping down all those
Oh.
things.
Okay. She wants to put them in boxes with an equal amount in each box. Write a division fact to show how many muffins would be put in each box. Excuse me. Let's read this again because that was very noisy, right? Sophia has 40 pumpkin muffins. She wants to put them in boxes with an equal amount in each box. Write division facts to show how many muffins she could put in each box. 5 boxes. So start with your dividend, which is 40. And then what are we going to do?
5 by 5.
Well, before we do, we need to write the equation. You're right, Griffin. So let's write the equation. We need to start with the dividend, which is what?
40.
40, thank you. Now what? Divided by 5. Equals.
And then
Now we'll do what Griffin said.
5, 10, 15, 30,
Nope.
20.
Let's start again.
5, 10, 15, 20, 25, 30, 35, 40. It is 8.
8. So if she has 5 boxes, there's going to be 8 muffins in each box. Okay. Put an 8 right there on that little line. Who'd like to do the next one? No, you just did that one.
It's fun.
Ruben, give us the equation.
Okay. 40 divided by 8.
Does he need to skip count, or is the answer kind of right there in front of us?
Yeah.
Ruben, what's the answer?
8.
If 40 divided by 5 is 8, then 40 divided by 8 must be
5.
yes! We don't need to skip count, do we? Good job. Put a 5 on the little line. But Griffin has his hand up. So Griffin, would you like to do the last one?
Yes.
Okay.
40 divided by 4.
Well, yep. Sorry, you're correct.
4, 8, 12, 16, 20, 24, 28,
2.
36, 40, 10.
10. Muffins in each box. That would be my favorite because then if she gave me a box, there'd be the most muffins in there, right?
I'd rather just get a 5 box.
I'd rather
just
have
a 40 box.
I'd rather have all of them. I'd rather just have all of them.
Gideon's like, I'd rather she doesn't put them in boxes and just gives them all to me. Okay, number 8. Thank you. Tom and Tanya each took a quiz. Check their work and circle any wrong answers. Tanya's quiz, let's do her first. 6 times 9 is 54?
Yeah.
Correct. Give her a check mark.
What's wrong? Good job.
15 divided by 5 is 3?
No.
5, 10, 15?
Yeah.
Yes, it is. 3 times 6 is 18?
Yeah.
You count your 6s. 6, 12, 18? That's a yes. 32 divided by 8 is 6. 8, 24, 32. Uh-oh. Circle it.
I just about check.
She got that one wrong.
I put an X.
Yeah, but it says to circle it.
Grab it.
You can put an X as well. Okay, let's see how she does on the next one. 7 times 9 is 63. 9, 18, 27, 36, 45, 64, 63. Last one. 24 divided by 8 is 3.
Yes.
8, 16, 24. She did pretty good.
I bet Tom's gonna get like a bunch
Let's
wrong
look at Tom.
in one line.
18 divided by 2 is 9.
Yep.
9, 18. Yes. So far, so good, Tom. 5 times 5 is 25?
Yep.
Yep.
Are you kidding me?
Another way to say that is 5 squared, right? 5 squared. You guys remember 5 squared?
Yeah.
With the exponent?
5 times itself.
It means 5 times itself. 54 divided by 9 is 6.
Yes.
Let's check.
9, 18, 27, 46, 45, 54.
So far, he's doing real good. 9 times 6 is 48. Oops. Okay, so that is related to the one above it. He should have gotten that one right.
Yeah.
Yeah. 27 divided by 3 is 9. 9, 18, 27. Yep.
He practically just did it.
And 7 times 7 is 49. Did he get that one right?
No.
Remember the touchdowns?
Yes.
Remember the San Francisco 49ers? Okay.
It's like he cheated off whole paper when she was doing another one.
Yeah, maybe.
Or maybe Tanya cheated off the
But they have different ones.
Heartbeat.
wrong on the same spot.
No, they didn't have the same problems.
I know, but it's wrong on the same exact
I know, isn't that weird? Heartbeat. Rewrite any incorrect facts with the correct ones and explain a strategy that can be used to solve each one. Tanya. Okay, let's do the rewrite first. Ready? We have to start with 32. Put the rest and stop before you write the quotient, okay? Now, she got it wrong. We need to put a different quotient. Do you guys remember what it is?
It was 6.
That's what she put.
I mean, this is wrong.
All right, skip down to 8. 4, 32.
Oh my gosh.
I have 4 fingers up.
Me too.
Okay, guys? 4. That's why you have to keep your fingers up.
Oh my gosh.
So what strategy did you use that helped you get it right?
Counting.
Do I have to say I skipped this?
No, you're just telling her to.
No. It's February 3. Well, I'm using this planner. Shoot. Do it. I was about to write with count.
Yes, you were. Okay, we are going to go to Tom's. So let's write his correctly. 9
Times 6 is 54.
Thank you, Gideon. And Gideon, what strategy could he have used that's even better than skip counting? We all talked about it. What could he have done?
Look above.
Look above. Yeah, look above. He had a problem right above it. That is the inverse of the one he just did. He needs to just look above. And he didn't, did he?
He was so close.
Yeah.
Look.
He could have gotten better than Tanya.
He could have, huh?
But he decided to go really fast through it.
I'm doing correction making myself.
Okay, number 9.
But some of them do division and times. So did you ask about
Yeah, but if he had looked above, right, the problem right above his was the inverse of the one he got wrong. Which could have helped him a lot, but he didn't. Okay, ready? Number 9. Use the numbers in the box to write the multiplication problems with products of 8, 16, and 24. 16 is a product using these numbers. Anybody?
You do it.
You do it.
Me?
Yes.
Okay, I'm going to do, remember, to get a product, we have to do what?
Times.
Times. We need some factors. I'm going to do 4 and itself. 4 times 4 gets us to 16, right? Can anyone think of one more way, though, only using any of these?
4 plus 4?
No, you can't get a product from plussing. You get a sum from plussing. You get a product from times. Griffin?
3 times 3.
No, 3 times 3. Gideon?
4 times 2.
No, that only gets us to 8.
3 times 5.
But can we put Gideon's in the middle here?
Yeah, that's what he was trying to do.
Okay, but I want to stick with 16. There's one more way, but let's
3
put
times
Gideon's.
5.
No, that gets us really close. 3 times 5 gets us to 50. 5, 10, 15.
8 times 2.
8 times 2. There we go. There we go. We did it. Okay, are there any other ways to get to 8 as a product?
Yes.
I don't think so.
2 plus 4?
We can't do plus though.
I mean 2 times.
I suppose we. Yeah? Do you guys agree?
No.
It's just backwards.
No,
It's the
we
commute.
shouldn't.
It's using the
I'm
commute.
doing
I don't want to. It'll make it.
I'm doing it.
I did it.
You can't.
8 times 1.
Well, there is no one. Gideon, look. The number 1 is not in there.
8 times 2.
No.
Can't do that.
No. 1. This was.
Yeah, Gage is saying he's going to use Silas's trick over here and flip 2 times 8 and put flip 8 times 2 and put 2 times 8. So if you really want, you can do that.
It's fine with me.
They didn't say you couldn't, did they?
They didn't say you
They didn't say you
either.
could and they didn't say you couldn't. So let's go to the last one, 24. Ooh.
12 times 2.
12 times 2.
12 times 2.
Yeah.
2 times 12.
2 times 12 and 12 times 2. Okay. You guys are using the commutative property a lot. There are a couple other ways to get to it. Yeah, there are.
6 times 4.
6 times 4. Which means we could also do 4 times 6. And there's another way. Oh my goodness.
Oh my god.
Gage, what do you think it is?
1 plus 1.
I wonder if Gage can get it.
times 8.
No, that would give us a huge number.
Yeah,
Or million.
2. 8 times 4. Wait, it has to be 8.
It is 8 times
Million.
something.
8 times 6.
Ooh,
Million.
that gets us. Look at your 8s. That's 48. That's too much.
Wait, you could also do 2s.
Well, we did 2. 2 times 12 and 12 times 2.
6 times 4.
We did 6 times 4 and 4 times 6, but there is one more way.
8 times 3.
Yes! Got it.
How did
8, 16, 24, right? 8 times 3. And that means 3 times 8 would work.
I can only fit.
Wow. Lots of ways. So I guess we get to circle every single number. The quickest way to do that is this. It's easier than drawing a circle around each
Or you could just do this.
one. Yeah.
But some of them we have to do more than once.
I know, but I'm not gonna.
I'm gonna circle
It's
all
too much.
12
I'm
times.
gonna do it.
Oh my.
I'm gonna circle all of them.
Okay.
Okay, no, I want to go to the last one. So everybody sit up. Silas, do that later. Silas, later. Number 10. Which statement is correct? Select true or false. A. The product of 2 times 3 is 2 times the product of 3 times 2.
No.
False.
Super false.
False. False. False. False.
Okay.
Falser than false.
Falser than false. B. 7 times 4 has the same product as 4 times 7. Yep. Commutative property, right? Definitely. So that's true. C. 9 times 6 has a product that is equal to the dividend in something divided by 96.
Ding.
Yeah, ding, good. Gideon, what's that mean?
Yes.
Yes, good job, buddy.
And then he's gonna switch with his dings.
So those are inverse, right? 9 times 6 would be 54. 54 divided by 9 is 6. Those are inverse operations. Okay, D. The product of 9 times 8 is 2 times the product of 9 times 4.
Ding.
What's that mean?
No.
No.
Yes.
Yes.
You guys, you can't just guess.
It means yes.
Good. That's the distributive property, by the way.
When it's wrong, we'll say dang.
Just watch. Watch. 9 times 8 equals 9 times 4 plus 4, which equals 9 times 4 plus 8 times 4. That's the distributive property. Okay, that's the truck
Ding.
right there, distributing to 2 different places. No,
Yes.
don't draw anything. Just remember that one's tough. Okay. E. 3 times 5 and 5 times 3 are inverse operations.
Ding. No.
No.
Ding. Ding.
That those things
Times
meant no.
cannot be opposite of time. What is the opposite of that? Division. So you can't. Times cannot be the opposite of itself. So that is unfortunately false. They are commutative though, aren't they? 3 times 5 and 5 times 3, are they commutative?
Yes.
Yeah, somebody just switched the factors. Done.
Yay, we're done with the packet.